So now let's see some examples in game cards, in the card game. Okay, card. So set of card. There are the heart, diamond. Okay, heart is in red. Diamond in red, and club and finally the spade. So 13. So there are 13 heart, 13 diamond, 13 club, and 13 spades. So altogether you have 52 cards. Okay, so now let's see. The trial is like this. So you have two set of card. The first set, and then this is the second set. So they were well shuffled. Well shuffled before in each trial. Before each trial, they were well shuffled. So now, what is the probability you get you will get both ace card, both. So uh, from the two sets, so you pull one from the first set, you pull another one card from the second set, and then you get both the ace card. What's the probability? And let's call X. You pull one. You pull an ace card. Okay. Specifically the diamond ace card. Diamond ace card. So you change the color. So event X is pulling is pull out a diamond ace card, and even Y also let's use black, also a diamond ace card, okay, from set number 2, okay, and X is from set number 1. So from both set, okay, so you take one card from both set, and you get both card. You get from both set, you get both diamond ace cards. So what is the probability? So now the probability of X. So is because this is only one in the set. Okay, in the set is only one diamond is cut. So probability is 1/52. So similarly for y is also 1/52. So you pull uh, from set number 1, and then you check the card, and then you pull from the set number 2, you check the card, and what is the chance that both cards are ace diamond ace cards? So that is probability of x and y, right? So that is the probability of x and probability of y given that we get x. Okay, and the point here is that what is probability of y given x? Okay, so it is important to notice here that the probability of y. Okay, so the success of getting a diamond S card here has nothing to do, okay, with either you get a diamond S card from set number 1, right? So event x and y are independent event. So x has nothing to do with y. So that is just the probability of y. So it is probability of x times the probability of y, which is 1 over not 15, it's 52. 1/52, and that is 0.00037. Okay, and so that is both ace diamond card. So what about if I change the question, either from set number 1 or from set number 2 you get the diamond ace card. Okay. So the second question is what is the probability of either from 1 or from 2 it is the diamond ace card. So that is probability of x plus y, right? And we seen previously it is the probability of x plus the probability of y minus the probability of x and y, and we have seen just now x and y are independent events. So So it just the probability of x times the probability of y. Okay, here. So that is 1 over 52, 1 over 52 minus 1 over 52 times 1 over 52. Okay, and you get 0.038. So you see, it is easier to to uh, to get this outcome rather than the first one, right? So that is an example. Okay, now let's move on to a die. Okay, let's think about a die. A die, there are six faces. One, maybe here three, here two. Okay, so the side that we cannot see from this surface is so this is one, three, two. So that thing numbers that outcome that you cannot see are 4, 5, and 6. So so this is a fair. Let's call this a fair die. So what's the probability of getting outcome 1? So that is 1 over 6. Okay, and that's equal to getting the outcome 2, outcome 3, outcome 4, 5, and 6. Of 6. So I'm run out of space there. So they are all equal. Okay, so the question, the probability, what is the probability, okay, when you in a single throw. Okay, you throw the die once and then you get either outcome 2 or 5. Okay, so that is either 2 or 5. So that is the probability of outcome 2 or 5. So this is mathematically expressed. So that is probability of 2 plus probability of getting 5. Okay, so minus probability of 2 and 5. 2 and 5. So I put a dot here to express the probability of 2 and 5. Okay, so the concern here is what is probability of 2 and 5. So that is probability of 2 times times the probability of 5 given 2, right? And the things here is, okay, you this is a single die. You throw it once, so you at the same time you cannot have two outcomes, right? So you cannot have outcome 5 and outcome 2 at the same time. So these two events, okay, so they are mutually exclusive. So this is the probability here must be 0. Okay, so regardless whether the two events are independent or dependent, okay, when they are mutually exclusive, so the probability of having them together at the same time must be 0. So this term is 0, so that your answer is P2 plus P5. So it is 1 over 6 plus 1 over 6, which is 1 over 3.